It's time to panic. What number? That's a vertical asymptote. Okay, so no, when the denominator is 0, that means you have a vertical asymptote. At some point, yeah. Right? So the denominator is 0 at... Because that helps me figure out where the denominator is 0. Okay, so that works. Okay, so since you plugged in 0 and you got that as an answer, that means there's a vertical asymptote at x equals 0. Oh, I see where you're going with that. Because we were trying to plug in 0 to find the y-intercept. Got it. There isn't one. Because there's a vertical asymptote at x equals 0. So the graph gets closer to it, but it never actually crosses the y-axis. So the y-intercept or the vertical intercept, you would say none. None. Nope, you just say none. For the vertical intercept on number 15. Yeah. Yeah. Okay, questions? To find the horizontal intercept? Yes, you set the... you have to either factor it or use the quadratic formula. Which one would you like to do? No, but would you like to factor it or use the quadratic formula? Yeah, for the numerator. I could, yeah. Could you? It's tricky when there's a number in front, but you know it's going to be 3x and x, right? Okay. And then one's going to be plus and one's going to be minus to make this be negative. So the trick is I have to have two numbers that multiply together to be 4 and add to be 4, but I have to triple one of them before I add them together. 3 and 2, 2 and 2, and I'm going to triple, yeah, so 2 and 2. Then 3x times 2 would give me 6x. And then if I subtract 2x, yep, you got it, then that'll be, that'll work. I want to triple the positive one because the middle term is positive. So I need the bigger number to be positive. Because, what's that? It's weird, but when I write it in this other parentheses, if you think about how foiling works, I would go 3x times x is the 3x squared like we wanted, and then 3x times 2 is 6x. So that's when that gets tripled. And then minus 2x would give me 4x. Negative 2 and 2 gives me negative 4, and then I'm in good shape. Yeah, it is weird, I know. When there's a number in front, the factoring is a little... Yeah, yep, and those are your horizontal intercepts. Okay? Yep. Questions? No? 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 Questions? No? You do have a question. And I think the answer is yes. But I'm probably the wrong person to ask. Okay? Anybody else? What? Someone much younger than me, someone hipper than me that knows like what irony these days is. Maybe my daughter, she lives in Portland, you know, she's pretty in like no, I know, but it conjures, you know, it brings back, you know what I'm saying? No. It's like we're different people. No, I know, but you make me think of him, and then it's like I get like the yeah, exactly. So, what my point is, you can't really blame me for ignoring you. I'm not really ignoring you. I'm really ignoring Matthew. Okay, what are we trying to figure out here? What are we trying to figure out here? Horizontal and vertical? Okay, which do you want to do first? Okay, how do you do the horizontal ones? No, other way around. Yeah. Just the top. Yeah. When you set the bottom equal to 0, that gives you the vertical asymptotes. Okay, are you ready for the vertical intercepts now? Okay. So for the vertical intercepts, you plug in 0. So that's going to be -1 times 3 times -5 divided by 4 times -4, which is 15 divided by -16. All right. I don't know. We now know how to find the intercepts and the asymptotes. Okay. Yeah, still 3.7. Okay. So nope, this is going to be it. Our last piece of the puzzle now is that we can either take a look at the graph of a rational function and use it to figure out an equation, or, of course, we can take the equation for a rational function and use it to figure out a graph. Okay? So that's the last part, is to take into account all these things that we figured out and put them all together into a graph. All right? So a couple things that you have to understand first. There are two basic behaviors that are going on when we're doing rational functions. This is one of them. What is the equation that would produce something that looks like this? 1 over x. Very good. And so what that means is we are going to just extrapolate from that any time the degree of the denominator is odd, you're going to get something that looks like this. In other words, one part goes this way and the other part goes that way. We don't know necessarily which way the two parts go, but we know that if the denominator is odd, one's going up and one's going down, or the other way around. Okay? Which is different from this one right here, which is 1 over x squared. And so what that tells us is if the denominator, the degree of the denominator is even, the things are both going the same direction. Okay? They're both either going up or they're both either going down. Okay? What about what? Well, 1 over x cubed would be denominator is an odd degree. So if I do that on Desmosis, then you'll see that it doesn't look exactly like 1 over x, but that's not the point. The point is that it looks close enough that we don't mind being wrong just a little bit. And that's going to be true no matter if it's to the 3rd, the 5th, the 7th, the 9th, the 11th, the 13th, the 15th, the 33rd. That's going to get weird because it's such a high exponent. But again, yeah, it looks square. Again, the point is one side of this asymptote, it's going up. One side, it's going down. I know there's a temptation to think that that's square, but if you zoom in, you can see there would be even greater temptation then to think that it is square, but you would still be wrong because there's 3,333. But if I zoom in enough, you can begin to see a little bit of a curve there. Okay, so that's totally fine. I'm okay with that. I'm not going to lose any sleep over that. I might lose some sleep about salsa, but not about these things, okay? All right, so here we go. For example, let's take a look at the graph of x plus 1 squared times x minus 3 divided by x plus 3 squared over x minus 2, okay? The first thing that I would suggest you do when you're faced with a crazy creature like this is find the asymptotes and the intercepts, okay? So somebody give me some asymptotes or some intercepts. Okay, so if I plug in 0 for x, then I can really quickly find the y-intercept. This would be 1 times negative 3. This is 9 times negative 2. So that would be negative 3 over negative 18. So in this case, the y-intercept is 1/6. So you can see that right here. It's really close to the x-axis, okay? So there's our intercept. How about the x-intercept? Where does the top equal 0? At negative 1, which means I have an x-intercept at negative 1, and also at positive 3, which means I have an x-intercept at positive 3, okay? So there's our intercepts. That's a great way to start by putting those on the graph, all right? Now let's put the asymptotes in there. Which do you want to do first? Horizontal asymptote. Top heavy, bottom heavy, or equal? What is the degree of the top? 3, because this is x squared and that's x, so that would make x cubed. What's the degree of the bottom? 3, because this is x squared and also x would make x cubed. So x cubed and x cubed would cancel and give you 1. And so that's why you can see that right here at y equals 1, there appears to be a horizontal intercept, okay? Where are the vertical intercepts? Where does the bottom equal 0? Good, negative 3, because that's what makes that 0, and 2, because that's what makes that 0. And so here is negative 3, and here is 2, and you can see that those intercepts are there, okay? So you can slap that up there pretty quickly from all the stuff that we've been doing for the last week. Now you just have to apply that odd-even denominator rule to see what's happening on either side, okay? You know right here at x plus 3, that's squared, that's even. So what that tells you is that the parts of the graph are both either going to be going up around this asymptote, or they're both going to be going down, okay? And then this one at x equals 2, you can see since this is to the first degree, that one of them is going to be going up and the other one's going to be going down, okay? Yeah? How do you know if it's up or down? Yeah, that's a great question, and the way that you know that is that you would start by drawing in this piece right here, because you know it has to go through that point, right? And then it has to have an asymptote there and an asymptote there. And then you'd go, oh, well, this was an odd power on the denominator, so that means the other one has to be on the other side like that. Okay? And you know, how do I know that this can't go like that? I guess, yeah, because then this would have, these would be going the other opposite directions from each other, and then that wouldn't work, okay? And you know, this one can't go down because there's no y-intercept over here on the left, so it's forced to go up. So you kind of have to just like fill in some spots, all right? Okay, are you ready to try this with a blank slate? Okay, all right. So let's sketch a graph of x plus 2 times x minus 3 over x plus 1 squared times x minus 2. Insert the graph. Oh, you want me to go and be like a good teacher? Okay, I was just going to draw one by hand, but thanks for making me be a better person than I was 5 minutes ago. Inspirational stuff. Okay, so there's the graph. All right, what do you want to do first? Intercepts. So give me some intercepts.
-2 and 3.
-2 and 3 would be the the x-intercepts. Okay, so I'm going to put a dot at -2, and I'm going to put a dot at 3. All right. To get the y-intercept, I have to plug in 0. So that would be for all of it. So that would be 2 times -3 divided by 1 times -2. So that is, which is also known as 3. So now I have a vertical intercept at 3. Okay. Okay. Asymptotes. What do I got going for asymptotes? I got -1 and 2 for my vertical asymptotes. So -1 and 2 for my vertical asymptotes. What's my horizontal? Good. This is, yep, no, you're right. This is bottom heavy because the top is just going to be x squared if we FOILed it out. And the bottom is x cubed if we FOILed it out. So that means it's bottom heavy, so that means that the graph has a horizontal asymptote that looks like that. All right, are we ready to draw it? Okay, what you got? On either side of this asymptote, it goes the same way, right? Because this is squared. Okay, I know it crosses the y-axis here, but it can't cross the x-axis down there, right? Because we didn't find any intercepts there. So I'm going to put like a little parabola-ish thing right there. Yeah, let's go with that. What else would it be? It can't be anything else because I can't turn around and go down this way. I can't cross the axis. Well, no, but I got an asymptote there, so it can't go. So it's like boxed in. Because it is. Okay. You're welcome. All right. Then x minus 2 means that this is the asymptote x equal 2. Is this going to be up here next to it or down here below it? Down, because this is odd. So that means this one is going to be down below. And this is weird because I have to go through this point here, but then I also have to like have, ooh, that worked out pretty good. I have to have a horizontal asymptote at y equals 0. Okay? And then the other one is going to go the other way. Good, because this asymptote came from the x plus 1 squared. So since it's squared, they're both going to be the same direction. So I'm going to kind of like go through there and then come back to it. And so my graph looks roughly like that. Okay. Did you guys have time to copy this masterpiece down before we check to make sure that it's actually, I'm going to graph it on Desmos. It's going to be like a straight line. You guys are all going to just get up and walk out. Go, this is it. This is dumb. I can't take this anymore. Hmm? For this middle piece, that's what Cooper was asking too. I knew that it was going to cross the y-axis here, and I knew that it can't cross the x-axis because there's no other thingies. So that really only leaves me that as an option.
Okay, you didn't look at the equation.
No, I didn't look at the equation. How come it what? Go through here, then like this? Because then I wouldn't have a vertical asymptote right here. No, this vertical asymptote is going to be for like both. Okay, so here's the way I know it doesn't go like that. Because 2, if I try to plug that into here, I get 0 on the bottom and that's undefined. So I know that this piece can't go through either one of these asymptotes either. Okay? Okay. All right, let's take a look. Hold on. Did I get it wrong? Oh, okay, good. You made me nervous there. Okay, let me graph it first so that the rest of the class can be amazed, and then I'll take your questions. Was it x plus 2? I want you guys to know I actually like studied for this. X what? Minus 3? For this part I did, yeah. plus 1 squared, and then minus 2. And then, okay. Yeah, pretty good. Okay. I don't really know how they come up with like the funky shape here. We can use calculus to figure out what that point is right there, but we're not obviously ready for that yet. So I would probably mostly just put a parabola in there, you know. Negative b over 2a, yeah. Okay, questions about that? Okay, what? Oh, okay, let's go. Yeah. This one? Because my hand kind of just twitched that direction.
So it's not supposed to.
I don't really, I mean it is. It worked out the way the graph. See how it's a little lower there?
Yeah, but like.
How would you, yeah. So that's what I'm saying. I would normally, for you, just make a parabola. Do I want 3 to be the vertex? So you want to go, well, you know the vertex is going to be somewhat like halfway in between these two things, right? So I knew that once it got here, it'd keep going down a little bit.
I made 3 the vertex and then I realized.
That's, yeah. Because it's not in the middle, right? Yeah. It's not that important. Yeah, right. No, that's fine. That's fine. All right, so then the last thing is to go the other direction and be given a graph and come up with the equation, okay? All right, so I'm going to get us started. You ready? F of x. Yeah. Yeah. Oh, wait, there's more. Yeah. Okay, what's on the bottom? X minus 2, x plus 1, yep. What do we know about the x minus 2? It's got to be squared because on both sides of this asymptote, the graph is going in the same direction. So that means the x minus 2 is squared, okay? Okay, what do we know goes on the top from the fact that it crosses the x-axis at -2 and at 3? X plus 2 because it crosses at -2, and x minus 3 because it crosses at 3. Okay, that seemed pretty easy. What about the horizontal asymptote? Is it bottom heavy? Did that work out? Yeah, because we've got cubed on the bottom and squared on the top, so we're good there. Okay. What about this bad boy right here? That's the only thing we haven't used yet. Yeah. There you go. And if I plug in 0 for everything, what do I need to get as an answer? -2. Okay, so if I plug in 0 on the top, I get -6. If I plug 0 in on the bottom, I get 4. So I get -3/2, which is not -2. So I need to multiply -3/2 by something and get -2 as an answer. What is that something? Not quite. If I solve this for a, I would multiply by 2 and divide by -3, right? Multiply by the reciprocal. So that would tell me that a is equal to 4/3. So what I'm going to do is I'm going to put a 4 here and a 3 there. Because now if I take this and multiply it by 4/3, 4 times -6 is -24, 3 times 4 is 12. That would give me -2. Okay? You understand I got the -3/2, right? And you understand I need that to equal -2, right? Okay, so I just set up a little equation, -3/2 times something equals -2. And then I multiplied. I didn't really show my work, so let me do that. To solve this for a, I multiplied by the reciprocal. So I multiplied both sides by -2/3. So then those canceled, and then A equaled 4/3. Okay? And then we got it. And I'm not going to graph that to confirm that it makes this. You can check it on your own if you want. I feel pretty good about it. Okay? Peanut butter pie would be the word of the day for Cassandra. Okay? Okay. We also have some different kinds of asymptotes, which I don't know that it's worth getting into, but I'm just going to show you. Sometimes you can have graphs that have, nope, never mind, I didn't cut and paste the pictures of the graphs. Sometimes you can have asymptotes that go diagonally, okay? So that's a completely different animal. You can even have asymptotes that look like parabolas, and the graph sort of follows that. But I feel like, nah. Are you okay with that?
Yeah.
Okay. I know, isn't that weird? I don't know why that is the case.